All right, since everyone here is ready to go, let's see if we're actually ready. Are you ready? Are you ready? You ready? Okay, you sure? Okay, so, all right, class. That's weak soup right there. That's weak soup. That's barely warm water. Okay, that's not even salt added to the water. Okay, that's how weak that soup was. Okay, that's like calling a cup of water a cup of soup. That's how weak that was. No flavor at all. So let's try this again. Okay, so when I say class, you say yes. Class. Yes. Thank you. You can at least, try to be, super excited about being here. I if you guys pretend like you want to be here, it makes it easier for your teachers to pretend like they want to be here. Actually, I love this stuff. So anyway, all right. So limits of function using properties of limits. Now, hopefully my smartboard will be working here in a moment. So hopefully this works. Says basic limits. Okay, limit of a constant. What this is saying that if the function f of x is equal to a, where a is a constant, where it's equal to some number, a constant, right? That's what a number is. A constant has no variables. Is pi a constant? Tree, is pi a constant? Is pi a number? Is it a variable? Try again. So pi is a constant. It is a number. So right here, then for any real number c, the limit as x approaches c of f of x is equal to the limit of a, which is equal to that a. So of a constant, that means that for the c, there is no variable to plug in. So if it's just the constant, that's what it is going to be. So instead of saying the limit of 5x, you're saying the limit of 5. There's no constant, right? Or there's only a constant. There's no variable. So that's what that means. Limit of that identity function. So if f of x is equal to x, then any number of c, the limit as x approaches c is going to be limit of x equal to c for that function. Some people that don't pay attention just put earbuds in and stop paying attention and then come and say that you didn't know that something was supposed to be happening. So yeah, go back to your phone. It's all right. It's not like I'm gonna judge you. Guess what? I'm gonna judge you. I'm very judgy. I don't know if you realize that yet. Okay, so find the limit of a sum, a difference, and a product. If f and g are functions of which that the limit of f of x as x approaches c and g of x approaches c both exist, then the limit of f of x plus g of x as x approaches c exist, then you could separate these two limits into right here, the limit of f of x as x approaches c plus the limit of g of x as x approaches c. So the limit of both of those individually. Are you really on a phone call?
Yeah.
What kind of crap is that?
I'm sorry, I just cannot stay awake.
Why are you on a phone call while we're trying to do some math here?
It's alright, I can stay focused, right?
Not really. Do you know what you could do? If I'm boring you, just work on your AP problems that you didn't do on homework. You want to do that?
I'm doing both. Is it alright?
By both?
I'm doing both. I'm just like very out right now.
Okay. So,
I haven't slept for the past day.
do you know what multitasking actually does?
But
Half-assing everything. So, if you focus on one thing, then focus, lock in. Don't split your focus.
it's alright, I can lock it.
At some point, I'm hoping you might.
I'm locking it right now.
Yep. Find the limit of a sum, a difference, and a product. So, same thing that we said, individually, if I have the limit of all of this, I could break it up into two separate, the limit of f of x minus the limit of g of x, as x approaches c on both of those. I could break those up into two separate items. Now, these all this inside here, the f of x and the g of x, are terms. They're terms. So each one individually, a plus and minus in between it. So I could actually separate those out. Yeah? And knowing this is going to help you out because sometimes some problems get really complicated. And if you break it up into smaller pieces, it makes life a whole lot easier. Okay, finding the limit of a product. Okay, what type of problem is this going to be? Am I going to have to worry about a left hand, right hand, any of that? No, this one's just going to be a simple, what? Evaluate, right? I'm just going to evaluate. I'm just going to plug in the number. So the limit as x squared approaches 3, I don't have any weird holes. I don't have any weird, graphs. This is just that I'm going to have x, okay? Wow, why? Oh, I clicked the wrong one. Sorry, my board's still freaking out. They haven't decided to fix it yet. Okay, there we go. So I'm going to plug this in and I get 9. Plug it in, get 9, right? What about the next one? If I plug in -5, I can just evaluate that and I get, what should I get? 20. Positive 20 or negative 20? Positive 20. Now for this one here, I can evaluate this. I can also separate it, distribute it. I can do all kinds of stuff. But I think evaluation is going to be the easier thing just by plugging it in to see what I get. Now for this one, if I plug in 1, that's going to be 5, right? Inside the parentheses, right here is going to be 5. And that's going to be times 2. 2 times 1 is just 2, which my limit is going to be 10. What about this next one? This next one's going to give me kind of a weirdness on it, but shouldn't be too bad. Can I plug in 2? If I plug in 2, what do I get? So 2 minus 2 is going to give me 0. And then 4 times 2 is? Yeah, that's an 8 times 0. So yeah, my board's acting up. So 8 times 0 is 0. Now, if I'm thinking about it and going from the right-hand side, what number's to the right of 2? How about 3? 3 is to the right of it, right? Number line? Okay, so if I do 3, that would be, let's see, 1. And that's going to be times 12. So that's going to give me 12 on the right-hand side of that. So that's a big jump right there, right? So this one, if I do my distribution, what's going to happen there? What am I going to end up with? Am I going to end up with the parabola? If I distribute, I should get it's a ghost. It's haunted. So if I plug this in, I should actually get 8x minus 4x squared. All right, I guess no smart board today. So 8x minus 4x squared. And if I go through and graph that, I'm going to have a pretty little parabola. Yeah, I already came prepared for this thing to mess up. All right, we said 4. Is it Monday? I feel like it's a Monday. Yep, it's a Monday. All right, so yes, we get a parabola. So as this approaches to this side right here, you know what? I'm just going to pull up the graph because I am not going to be able to draw that graph. For you watching at home right now, this is my real face. I'm in Grumpy Cat right about now. Four x parentheses 2 minus x. There we go. There's my parabola. So I can clearly see here, as it is approaching 2 from the right-hand side, 2 from the right-hand side, going this way, it's coming up to 0. And then from the left-hand side, it's also going to 0. But when I start plugging in numbers, it's going to be way up here. And if I were to plug in the number 3, it would go way down here. It would give me something right here. So as it's approaching from this side, I could evaluate it at that point to see that it was going to go there. The only problem I would have is if this was going to be undefined right here when it becomes 0. So on these notes, if this one right here became undefined at 2, this would give me an issue. So I would actually have to approach it by trying to get mathematically somewhere in there. All right, everything in here is haunted. Find the limit f x approaches 2 if it exists. Now, we're going to do this non-graphically because you have to do a lot of this non-graphically. So for right here, I'm going to start by plugging in and seeing what's going to happen as x is less than 2. So at 2, because I don't have anything undefined in here in this first part here, I'm going to see what this is as x is less than 2. I'm going to get this at 7. There we go. Wow, that was supposed to be an equal sign. That did not work out. Anyway, so now this is not equal to, but it is approaching 7 when it comes to 2. Now on this side, when I go to 2, this is going to be my left-hand side because it's all numbers that are less than 2. Wow. Yeah, this one's going to be from the left-hand side. This is going to be my right-hand side. So if I plug this in, if the limit exists, what does the left and right have to do? They both have to go to 7, right? They both have to go to 7. So let's see. So if I plug in 2, this side right here is going to be 4, parentheses, now 2 minus 1 is 1. So this side is 4. So the left side goes to 7, the right side goes to 4. Does this limit exist? No, it does not. No. Anyway. Find the limit of a power and the limit of a root. Limit theorem. The limit of f of x exists. So right now it's starting off, it's saying that it must exist. It is a positive integer, then from right here, f of x raised to that n value, it'd be the same as saying f of x raised to the same. So it's got to be both. It has to exist. Limit of a root. Okay, it's important that I actually identify the outside versus the inside. So whatever root this is here exists and n is greater than 2. What happens if n is 1? Yeah, it would, yeah. Yeah, that doesn't work out very well, does it? No. So that is important. So if it's greater than 2, yeah. Anyway, so right here, the function, it's the same as the limit being on the inside of the radical as being on the outside of that radical. So this is going to be helpful to actually change this back and forth. Limit as x to the 5th. What do we get there? $32, very good. Okay, right here. So now this is going to give me, so if I evaluate this one, plug in a 1, I get -1, very good. Limit as x to the n, a positive integer. Positive integer. That's important, positive integers. What does that mean if it's going to stay a positive integer? Even better, what is it if it's a negative integer? If it is a negative exponent, what happens to that exponent? You move it down, right? You move it down. Yes, it becomes a fraction. So we would actually change that up. So if it is a positive integer, okay, x approaches c, that would just give me c to the n. Okay, we're just plugging in c for that value, and then to the n. If it was a negative integer, that would be 1 over c to the n. Like that. And guess what? Oh, yeah, wait. What's the next one? Oh, yeah. So here's the last one for today. So 4 squared is 16. 16 plus 11 is 27. The cube root of 27 is 3. There we go. Good job. All right, that being said, I will leave off on this set of notes here. If you guys are done with the homework that's due today, okay, you can start on today's assignment, or you can finish the one that's due today. Make sure you like, share, and subscribe.